Welcome to Pomodoro Joe for Saturday, January 7th, 2023. And today's LeetCode problem is LeetCode 134, gas station. It's a medium level problem, and the problem description says, there are n gas stations along a circular route where the amount of gas in the ith station is gas at index I. You have a car with an unlimited gas tank, and it costs at index I of gas to travel from the ith station to the next I plus 1th station. You begin the journey with an empty tank at one of the gas stations. Given two integer arrays, gas and cost, return the starting gas station index if you can travel around the circuit once in the clockwise direction. Otherwise, return -1. If there exists a solution, it is guaranteed to be unique. And then they have some examples here and some constraints. So the basic idea is you have to start at some gas station, fill up your tank with the gas in that station, and then make it to the next station and keep doing that until you make the entire circuit. If you ever run out of gas, you can't complete that circuit, you try again. So here's our basic algorithm. We're just going to go through every single station, select that one as our starting station, see if we can make the circuit. If we make it, then that is our starting station when we return that station index. If we can't make it, then we move on to the next station, try again. Once we've exhausted all of the stations as starting stations, we return -1 if none of them give us a solution. So I already know that this will not run in the time that we need it to, but there are some optimizations we can make once we do this basic algorithm, and I'll show you how to do those after we start. So 25 minutes on the Pomodoro timer and we will get started. So again, the basic algorithm is we will go through each station in turn, treat it as our starting station, see if we can make the loop. If we can, we return that index. If we cannot, we move on to the next station. If we can't get any of them to work, we'll return -1. So let's start out with a start station. And for now, we'll just say it's none. And we need a tank, and that's going to start at 0. And basically for index in, let's see here. Let's have a station count. And that's going to be the length of the gas array. So we have a start station, a tank, and actually we're going to want to put these inside of our loop here. So for index in range of our station count, our start station is just going to be that index. And then we have a gas tank, which starts at 0. And then we are also going to want a current station. So we'll just call it station. And we're going to start it at the start station. All right, so in fact, let's just replace our index with start station here. So for the starting station in each station, we're going to say we'll start at that station with a tank of 0. And then I don't generally like doing this, but we're going to do a while true. Ideally, what I want to do is something like while our station doesn't equal our start station, meaning we haven't made it all the way around the loop. Unfortunately, I can't do while station's not equal to start station because the station starts as the start station. So what we'll do instead is we'll say while true, and then we will break out of the loop either when we have an empty tank or when we return to our start station. So just make sure that we break out. We don't want to have an infinite loop here. Okay, so while true, our tank, we will fill up our tank with the gas at this station. So gas at station. And then to get to the next station, we will subtract the gas that it takes to get to the next station, the cost at station. And if we are able to make it to this next station, our next station is going to be equal to our current station plus 1. But because this is circular, we need to wrap around. So we use mod station count. So if you're not familiar with circular arrays or mod, I suggest you take a look. But essentially what this is going to do is if our station plus 1 exceeds our station count, basically exceeds the limit of our array, by doing the mod, it will wrap us around back to the beginning. All right, now if our tank is less than 0, we can't actually make it to the next station. So we will break out of this loop. We didn't make it, we'll start over at the next starting station. If our station is equal to our starting station, this should be an if. So if we do make it to the end, we wrapped all the way around, then we can just return the start station here. We made it all the way around. All right, so we have two ways out of our loop. We run out of gas and we break out of the loop, or we make it all the way around and we return that station's index. If we don't find any starting station that gets us this return, then we have to return -1. We can't make it through this loop. So that's our basic algorithm. We'll run it, we'll just see if it works. I already know for a fact that this will not run in the runtime that we need, but I'll show you how to optimize this. It's a simple step to go from this algorithm to a more optimal solution. And as you see, we exceed this time limit. And look at this input. This is crazy long input. All right, so we exceed the time limit. We're going through every single one of these stations in turn and then trying to do the entire loop. This is clearly not an optimal solution. Well, how do we optimize this? The thing to realize, it's a little bit of logic, but if you get to a station, let's say you started at station 0 and you get to station 5 and you can't go to station 6. So if you get to some station where if you tried to get to that station, you would run out of gas. If you tried to get to the next station, you run out of gas. That means that you don't have enough gas at this very station to get you to the next station. So if you're at station 5 and you want to get to station 6 and you don't have enough gas, it means that station 5 itself doesn't have enough gas in it to get you to station 6. You need to have some surplus of gas already in your tank when you get to station 5 if you want to get to that next station. Okay, so that's the first logical leap you have to make, and you have to realize that if you started, so in that case, if you just started at station 5, you don't have enough gas to get to the next station. So station 5 cannot be your starting station. You've already eliminated one of your stations as a possibility, which is great. In fact, you've eliminated 2 because whatever station you started at, which is station 0, you've eliminated that. You already know that can't be your start station. The station that you end at, you've also eliminated that as a start station. What about all those stations in between? Well, all those stations in between either cost you all your gas or just enough gas to get you to the next station, or they leave you with some surplus of gas in your tank. But it means that all of that surplus of gas that you could have built up between your current starting station and this ending station that you got to, that surplus of gas wasn't enough to get you on to the next station, which means that none of those stations in between can also be your start station. So you've just eliminated an entire range of stations that cannot be your start station, because whatever surplus you could have built up to get you further, you still didn't have enough gas to make it on to the next station. So in fact, what we can do is when you reach tank of 0, you can say, instead of, okay, this is where I'm going to make some code changes. So instead of starting at your start station, so instead of saying for every start station in order, we're just going to say, while our start station, we're going to have some start station out here. So start station, we're going to start it at 0. So we're going to start at the very first station in our array. And while this start station, let's see, start station is less than our station count. So we're still going to go through each station. Well, sort of. We're going to eliminate large chunks of stations in our ranges, but we're going to start at 0 and we're going to work our way up to station count. But we can eliminate big chunks of stations at a time instead of just going one at a time. So we'll still have start station, our current station is equal to our start station, but then when we get to an empty tank, well, now we can say our start station is equal to our station plus 1, or our next station. We've already done the station plus 1 mod station count here. So this is the station that we cannot get to. Our tank is going to be negative if we try to get to this station. So we're just going to say that's going to be our start station. Now, one other little trick that you have to realize here, if you just set that as your next station, if you do set that as your start station, it is possible that you've already wrapped around and your next station actually is before your start station, your current start station. Let's see, I don't know how to explain this very well, but essentially it's like if you start at station 6, you could make it all the way back around to station 1 or station 0, and then you run out of gas. But we've already eliminated like station 0 from our possibility, like our range, we've started at station 0. So if we start at station 0, we know we can't make it. You get to station 6, you start at station 6, you wrap around to station 0 again, you couldn't make it. You don't want to start at station 1 or station 2. You've already eliminated those ranges. So you've essentially eliminated all of the gas stations before your current start station. So we're going to say your next start station is going to equal the next station in our list, but only if that station is less than our current start station. Otherwise, we're just going to jump to the end. We're just going to say, okay, you can't make it any further. Let's give this a shot and see if we're running okay. Oh, and it looks like I did not do this right. Let's try this again. So we're going to start station, less than station count. Okay, this all looks good so far. If we run out of gas, then we're going to say our start station is the new station. If the station is less than the starting station, okay. Oh, sorry. This is the wrong way. I meant if the station is greater than our starting station. If it's less than, that's when we have to jump to just the end, say, we're done. Okay. Now we'll submit this. And we pass. All right, this one is tricky, I'll admit. There's a lot of little pieces that are tricky about this one. The main things that are tricky, the brute force way gets you most of the way there, but not all the way. So realizing that you can eliminate these stations that come before the station where you run out of gas is one trick. Realizing the wrap is the other trick. Actually knowing about modulo math and indices is the other thing. So this is clearly a medium problem. A lot of little tricks in there. We do all right. We beat 78% in terms of runtime. We beat 74% in terms of memory. There's room for improvement for sure, but it's pretty clean. So I'd say check this one out. Try it on your own. Again, this is LeetCode problem 134 gas station. So yeah, check it out. Have some fun. Give it a shot. I encourage you to try all these problems on your own. Do some looking up the modulo math. Look at some other people's solutions. Anyway, you can really learn a lot from this problem. I think this is a fun one. This is a good one to study. All right, folks. Hope you enjoyed this. Hope you learned something. Hope I wasn't too incoherent. Go out there and write some better code.